Hi, this is David of Ferris. I want to show you quickly how to use our Atlas OpenDX tool along with PyMOL's volume visualization to view the density of probes and possibly use them to grow fragments or understand the density of fragments within a site. So what I've loaded up here in PyMOL is the mapping of 1THS, which is an unliganded crystal structure of thrombin. And I've also loaded in here the fragment that comes out of the 2C90 crystal structure, which is a X-ray based screen done by Aztecs on thrombin. So in this case, what I've done is I've gone ahead and enabled the consensus sites from Atlas that correspond to where this fragment binds, along with nearby consensus sites that on the surface of the protein, so that we can explore the areas that are possible for growing this fragment into a lead-like molecule. So the first step in preparing a OpenDX grid from mapping is to extract the probes that make up the consensus site. So to do this, we run our Atlas extract consensus sites program on the tar.bz2 file that comes with that is produced by mapping, and we list our sites afterwards. So we have 0, 1, 2, 4, 6, and 9, and we've directed that into an SDF file. The next step is to use our Atlas OpenDX tool with this SDF file, and we can send the results into a DX file. So now I've created this DX file. I can go over to PyMOL and say load 1ths underscore sites.dx, and when that's loaded into PyMOL, PyMOL by default doesn't have any representation for these grid files. Rather, you have to click on A for action, and there are a number of options where you can show a mesh, the surface, and so on. So what we're going to do today is use the volume representation, and there's only a default level for that, so we'll choose default, and what we immediately see are these sort of ISO levels that indicate a certain level of density of our probes. So if we want to modify how this looks in any way, we go up to here and we click the volume button, and what we see is that this ISO level type thing is this default representation PyMOL has, and it's made up of a triangle of 3 points, where this upper point is at is visible with a kind of red magenta color. And if we want to adjust this, we can click on it and pull it up and it becomes more intense, or pull it down and it becomes much softer. So this is connected to two other points on the baseline, so you don't see the blue, but really there's a gradient where if the density is at this level, then it will instead show a color between red and blue at this lower intensity. And we can see this a little bit by if I pull this out all the way over here, we now have kind of a, you can more easily see sort of this blue border of low intensity stuff along here, and you can see that gradient really. So let's pull it back over to where it was originally, so it's more like an ISO level. So we want to add additional levels to this graph. So let's say we want to, so on this chart over here is our lower density, so you can follow the scale at the bottom. And over here is our higher density. So if we control click, we can create something with 3 points similar to this. So I'll control click here at 0.05, and we'll choose the yellow color over here on our simple color chooser. And what we can see is that we now have another level that's further out. And I'll turn off our consensus sites so that we can just examine the densities and the various levels more easily. So we can also go over here and say make a blue at the higher density, and maybe I'll make that more intense so that we can see it a little bit better. So we can now see multiple levels of this volume representation, and let's maybe so if we want to just add a single point rather than a triangle like this, so if I click here, it will create a point that reaches out to, there's actually a point down here at this corner, and it will reach out to that point as well. So let's make this green. And, I say, I don't really like that. It's kind of a little bit ugly, so if I middle click on a point, I can delete it. So in this case, we can go ahead and look at what another fragment that came out of Aztec's hits. We can see that it agrees decently with our density when you consider the fact that we mapped an unliganded protein. We find the general area for where these two rings are, and we can also look at the molecule that's created when these two fragment hits were linked together. And so in this final molecule, I think the rings fall even slightly more inside our density than in the fragment hit, so that's a little bit interesting as well. And over here, where we have a tiny bit of density, it turns out that in this 2C93 crystal structure, this dimethyl sulfoxide kind of occupies that site. So that's how to use PyMOL's volume visualization with our OpenDX tool. OpenDX is a file format that was invented by IBM, as far as I know, and there are a number of visualization programs that are able to open it up. PyMOL is one of the more common ones for molecular modelers, so it's obviously able to open up proteins and small molecules as well. So that's why I decided to use that program to show this off to you today. Let us know if you have any questions. You can learn more about PyMOL's volume visualization at pymol.org/volume, or there's a YouTube video. If you search for PyMOL volume, it will give you a video showing use of PyMOL's volume visualization with electron densities, as well as some other interesting grid file types. So, like I said, let us know if you have any questions. I'm always available to talk or by email. Thank you.